and welcome to Amazement Square Anywhere. My name is Miss Jennifer, and today we're exploring weather. Now, weather is just the current state of our atmosphere. So, is it sunny, cloudy, hot, cold, maybe a little bit rainy? Now, a meteorologist is someone who studies the weather. And they're a scientist who's looking at data such as the clouds moving in, how much it's rained over the past few days, to try to make predictions about the weather. Now, some weather is easier to predict than others because there's some features of our atmosphere we have a better understanding of how they interact. One feature is hot air and cold air mixing together. So we're going to do a few demonstrations today about how those things interact. And we're going to start with our hot and cold air. And today we're going to be using some cold water and some hot water. So I'm going to start by pouring some cold and hot water into each of our sides here. I'm going to pour some hot water on this side and cold water in the other. Now our cold water is tinted blue, so you can see it a little bit better. And our warm water is tinted kind of a red-orange color. And I'm going to try to make sure there's about equal amounts of hot and cold water. So what I'm creating is a front. Now sometimes when we're watching the weather, maybe it's on the news, it's on the internet, we're seeing a meteorologist explain some things that might be happening over the next several days. We might see a picture of, say, the United States or area, and we'll see a curved red or blue line, and that's a front. So that's what happens when hot and cold air meet. Now, if it's a blue line, that means it's going to be a cold front. So the amount of cold air is larger than the amount of hot air, so it's going to overtake that hot air. And the same thing's true with a warm front when it's red. So the amount of warm air is larger than the amount of cold air. But here I've created a stationary front. So the hot air and cold air are about the same size. And we're gonna see what happens when they finally meet. So I'm gonna pull this center divider out. And what do you think is gonna happen? Are they going to stay on each side? Are they gonna mix together? Let's see. So we pulled it out. I don't know, let's see, there might be some mixing going on. I think there's a little bit of swirling. We see some things going back and forth. So when hot air and cold air meet, or hot and cold water, they are different densities. So you may have heard hot air rising and cold air sinking, and that's going to be true in our demonstration as well. So our hot water is less dense than our cold water. So we're going to see they're kind of mixing together a little bit, and they sway back and forth. Because when that hot and cold air first meet, that creates wind. So by hot air rising, it creates areas of low pressure, and the cold air sinking creates areas of high pressure. Now, high pressure air wants to go to the area of low pressure. Kind of like if we're all packed in a room together and there's an empty room next door, we're going to want to try to spread out to that empty room. And air is no different. So now we should see some layers. We kind of see that orange-red on top. So that's our hot water on top and the blue-red on the bottom. So that's our stationary front kind of mixing together a little bit, and it kind of creates a storm over top since one cannot overpower the other. Now, from thunderstorms, we might also get tornadoes. Now, that is a little bit harder to predict because you do need that hot and cold air mixing to create wind, to create your cyclone, but there's many other features of the atmosphere that have to be just right for a tornado to occur. So over here, we have a tornado machine, and it kind of simulates what a tornado or cyclone would look like. So we can turn it on and see how that looks, and I'll explain a little bit about how this works. So this just simulates what the cyclone looks like, but not how it actually forms in nature. So at the bottom, we have some fog that's being made. We have a pool of water sitting at the very bottom. And at the top, we have a fan that's generating some low pressure. So it's kind of sucking air out. That air at the bottom wants to fill in, so it's bringing it back to the top as well. But now on the sides, these tubes, they have little holes in them that are directing air outside, kind of like little fans around the side. And that's kind of all trying to spin it in one direction like a vortex. So you can see it's kind of pulling it up and creating that nice cyclone for us. But every now and then it breaks apart. So even just some slight air movement in this room is enough to break that cyclone apart. So just like in nature, maybe the clouds aren't quite low enough, or the ground isn't quite the right temperature for that cyclone to stay. So oftentimes we look for optimal conditions instead. So if you see something like a tornado watch, that means we are seeing optimal conditions that a tornado may form. The clouds are just about the right level and the ground's about the right temperature, and we're seeing hot and cold air mix into a storm. But until we see just a little bit of those cyclones forming, that's when we'll get into a tornado warning. Now, our meteorologists use many different tools to help predict the weather and gather data. Some of them are very simple and you may have around your home. So this one here is an anemometer, and it actually measures wind speed. So one of them is actually colored red, so it's easier for us to count how many times it goes around, say in a minute. And we can use that information to see how fast our wind is going in miles per hour. Some other tools include a barometer, which ours looks just like a clock, but it actually measures atmospheric pressure. So remember that high and low air pressure we were talking about earlier. So when we see low air pressure, that means it's more likely to be cloudy or overcast and maybe storm a little bit. As it moves over to high air pressure, it's more likely to be clear and sunny. Some other common tools include a thermometer. We'll often see degrees F and degrees C, or Fahrenheit and Celsius. So they're just different measurements that we use to measure how hot or cold it is. So right now in this room, our thermometer looks to be about 68 degrees Fahrenheit, so that's one scale we could use. Or on the other side, about 21 degrees Celsius. That could be another scale we use to measure how much heat is there in the room or outside. Another tool we could use after weather occurs, and that can be a rain gauge. So after a rain or storm, we see how many inches did it rain. So that gives us information about how the ground itself will be. Is it wet and saturated? So that gives us information about how another storm may interact. Now we can actually make some of these tools at home. So Miss Tammy made a great rain gauge for us, and she just used an old plastic bottle. So you can have an adult help you cut the top off of the bottle, and on the side, we used a ruler and permanent marker to measure inches to see how many inches of rain fell. So you can set your rain gauge out just like this, or you can use the top and set it inside like a funnel to funnel some water in as well. And after it rains, you can see how many inches of rain fell and make some of your own observations about the weather. So we encourage you to send us pictures and videos of you making your own observations and predictions, and your own rain gauges that you make at home as well. To see instructions about how to make your own rain gauge, visit our website at amazementsquare.org. To see more videos like this one, make sure to subscribe to our YouTube channel. And thanks for joining us, and we'll see you next time on Amazement